Hello everyone. In this video, I'm going to talk about lemmatization, stemming, wordnet, and we will understand the importance of this lemmatization and stemming. Let's start with the stemming. So what exactly is a stemming? So as you can see, stemming means mapping a group of words to the same stem by removing prefixes or suffixes without giving any value to the grammatical meaning of the stem formed after the process. What does it mean basically? Suppose say I have a data, right? I have a data. When I say data, it is nothing but any text, right? Let's understand with some example. As you can see, let me take this. Okay. So say that I have a word here, right? So computation, right? So when I apply stemming on this particular text, so what it will do, it will try to remove this last tail part, right? TION, and it starts from ATION, right? It depends upon the type of a word you have. It's not going to be same for all. So, and a computer, it will try to remove this ER. And hobbies, it will try to remove this ES, right? So basically what it means, so something like computation, right? Promotion. So things like that, the TION and things like that, it will remove that part and it will shrink. I mean, the word will shrink like this. So it is a base word, right? The root word or the base word. So this is how it is going to give me. So at the same time, it doesn't care whether the remaining word after stemming will make sense or not. It doesn't care anything. What it does according to its process, however it does basically, so it will try to chop off that tail part, keep the root word. And root word, whether it makes sense or not, that doesn't matter. There is no, it is not going to give any importance to the grammatical meaning, right? So we'll see some examples and understand in better way, right? So I can see here, we can see that stemming tries to bring the word back to their base word, but the base word may or may not have a correct grammatical meaning. All right. So, and there are a few types here. Again, Porter stemmer and Lancaster stemmer. Let's understand one by one. So first of all, how to use stemming part. So I'm going to import NLTK first. Then I will be able to import this Porter stemmer and Lancaster stemmer. And there is again a snowball stemmer. It is an extended version. So let's see that. So everything will be able to import from this guy. All right, let me execute. Okay, it's done. So now what I'm going to do, I'm going to instantiate this Lancaster stemmer and Porter stemmer and snowball stemmer into these objects. All right. So these are the objects that I'm going to use going forward. So now I will print a Porter stemmer so that we'll see that how Porter stemmer will work. At the same time, I'm printing this Lancaster stemmer so that we can differentiate, and I'm using a Lancaster stemmer. All right. So in both the cases, I'm giving the same text, right? Hobby, hobbies, computer, computation, right? Same thing goes here as well. Let's execute and see how these things will work. So in order to work, what I'm going to do, I'm going to use this Porter, right? Porter dot stem. Dot stem is a method that the stemming will be applied on these words. All right. Same thing goes with this guy as well, a stem. So let's execute. So Porter stemmer prints, I mean, after applying the stemming part, this HOBBY will be printed as a HOBBI, right? Hobbies also, printed as a HOBBI. Computer and computation will be, printed as a compute. So we know that this doesn't make any sense, right? So it's supposed to be, there's supposed to be E, so then it will make sense. But here stemming doesn't care that one. right? So that is how the stemming works. So basically the idea behind using this stemming is to minimize the word length as much as possible, right? At the same time, we want to have some kind of a meaning, but stemming does that. Sometimes it will not care the grammatical meaning, right? So there are other methods that we'll discuss after the stemming part. And yeah, so if you look into Lancaster stemmer, so it is working a little different. Here we can say that it is making sense. Hobby and hobby here, right? But when it comes to computation and computer, it is again making the same mistake. Let's not call it as a mistake, but yeah, stemming, that's how stemming works, right? So that is basically Porter stemmer and Lancaster stemmer. Now what I will do, I will create one sentence here. So let's say this is a sentence, right? So this entire statement I am going to store in this particular object called sentence. Then what I will do, I am going to apply word tokenization here, right? So we know that what is a word tokenize. So I'm going to apply that word tokenize, and I will call this sentence. All right. So it means that I'm going to pass this sentence and I'm applying a word tokenize so that I will get I was as each and every word I will be able to get. So it is going to be like a word by word, word by word. So all those words I'm going to store in this particular guy called a token. All right. So now I'm going to print the token. All right. Let's execute and see how things will work here. Right. As you can see here, everything is basically tokenized, word tokenized. So now what I'm going to do, okay, at the same time, if I print a sentence, this is the sentence. Okay, let's take this token, right? So all these tokens basically from here to here, I'm going to apply a Porter stemmer, Lancaster stemmer, and a snowball stemmer. Let me take out this. And here what I'm going to do, I'm going to use a for loop. So for every stemmer in snowball first time, then Lancaster and the Porter one by one, right? So I will use that first time. So I will apply a stemmer. This guy will be picked snowball first time, snowball dot stem. That T is coming from here. How? So for every T in a token, right? Token, we already have all those tokens. I'm going to pick one by one. So first token will be picked and will be passed here. And on top of that, I'm going to apply a stemming part here. And the result will be stored in this guy. Next time I use a Lancaster and Porter. So for each snowball, every time I will pick the token, pass here, store, pick the new token and pass it here and apply a stemming and store it here. So once I finish, then I will go for a Lancaster and then the Porter. After that, I'm just going to join all this stemming, STEMM. So then I'm going to print it. All right, let's execute. So you can see that this is the sentence we have, right? So if I apply a now snowball, so the snowball stemming will be, will give you this kind of a result. As you can see, I was go to the office, e missing, right? On my bike when I saw a car pass by, hit the tree, right? So here it is showing only GO. And when I use a Lancaster, so as you can see the changes here, I was going to the off. Here it's not even care that I see, right? It is just giving me OFF. Similarly, this guy, right? So each one will work, each and every one will work differently, right? But end of it, this is all a stemming part. So sometimes it doesn't give any meaning of the word, right? The base word. So in that case, I have a problem. All right. So there should be some kind of a technique that should be applied even after chopping off the tail part, the base word should give a meaning, right? So that is where this lemmatization comes into a picture. All right. I will show you that. Let me run this one more time, Porter stem. So here I'm giving running, runs, and ran. So if I apply a stemming part, so this is how it is going to give me. All right. Now, yeah, as I said, there is some problem with the stemming part, all right, because the base word is not giving a real meaning. So what I will do in order to overcome this problem, we have something called a lemmatization, right? Lemmatization also does the same thing as stemming and try to bring the word to its base form. But unlike stemming, it do keep in account the actual meaning of the base word, right? So that is the base word belongs to any specific language. The base word is known as lemma, right? The base word is known as lemma. So let's interpret and let's execute here. So how I can import this wordnet lemmatizer? I can import from the same guy, that is NLTK.stem, which we have used for importing the stemming part. Same thing I can use here and import the wordnet lemmatizer. So case sensitive, let me execute. And I'm instantiating wordnet lemmatizer into lemma. And I've used this lemma and dot lemmatize is a method. And I'm going to use the same guys, same words which I have used for the stemming. Let's see how this will treat this text. Execute. You can see it is taking a time, right? Just for 3 words, it took almost around 2 to 3 seconds. That is a problem here with the lemmatizer. That is the only limitation. When compared to stemming, lemmatization will take a time, right? So just for 3 words, it took 2 to 3 seconds. Now imagine that if I have a lakhs together text, how much time it is going to take. So that is one of the limitation we have in the lemmatizer. All right. Yeah. Now I'm going to execute with parts of speech equal to verb. Which the POS is basically parts of speech where I'm giving a verb. And if I use that execute, everything will be run, right? So unlike here, I did not mention anything. So here I'm getting a running. For a runs, it is a run. For a ran, it is a ran. And here for everything, it is giving me a run, right? So it lemmatized is very complex and takes a lot of time to calculate. That is what I mentioned here. Now let's see some of the important things like how we can interpret, how we can differentiate stemming versus lemmatize, right? So I have some word here, some words, right? There is no meaning in this sentence. Don't try to make any meaning out of it. This is just a word by word, word by word. Here I'm going to apply a stemming as well as a lemmatization, and we'll see that how both will differentiate these words when we apply both of them, right? So first I'm importing Porter stemmer and I'm instantiating into this particular object. So fine, that is a Porter stemmer. And finally, the text I'm passing here, this guy, let's use my pen here. I'm going to pass here and I will apply a word tokenize so that I get bring, king, going, anything, sing, things like that, right? So all those data will be stored in this object. Now what I'm going to do, I'm going to use a stemming here. So for that, have to read word by word. For every word in the tokenization, that is nothing but this guy, I use a Porter stemmer dot stem, right? Porter stemmer dot stem, and I will pass this word over here. And the same word I'm passing here, this is the original word. So this guy will go here. Stemming for first word bring is whatever the stemmed word, right? So that is how you can interpret. Let's execute. Hopefully things will be clear when I execute this. So you can see this stemming for a bring. Stemming for a bring is bring. Stemming for a king is a king. Stemming for going is a go. Stemming for anything is any th. So here it is going to make a mistake, right? It thinks that ing is just going, running, thinking like that. So assuming that it will chop off this ing and it will leave only anyth, and we don't have such word in a dictionary. Same thing with this nothing, right? nothing. Same thing with this guy, and there is no such word noth. So we can clearly see the problem with the stemming. What I'm going to do, I'm going to apply the same data and use a lemmatization. So I'm going to instantiate lemmatization. This is the lemmatizer. The same concept I use. Nothing is going to change except this lemmatizer. All right. And I'm going to apply a lemmatize. Now, if I execute, you see that everything is perfect. So you cannot remove ing because br doesn't make any sense, right? So anything is basically converted to anything only because it knows that there is no such word anyth. Similarly, nothing, right? It will keep in mind that, okay, the base word is going to have some sense, some meaning or not. So if it is not making any meaning, so then it will make sure that it will bring back to its original form, not original form, the meaningful form. Make sure that there is a grammatical meaning, right? So that is how the lemmatization works. All right. So as I mentioned, these things we use in a NLP in order to reduce the length of the words. At the same time, we do not want to lose the meaning of the word. All right. And there is something called a wordnet. So wordnet is basically to we can use for different reasons. One of the reason to find the synonyms and antonyms, right? So let's see that how will I import. So wordnet can be imported from nltk.corpus and import wordnet, right? So wordnet I'm going to import here. I am creating empty list here, synonyms and antonyms. So what I'm going to do, I'm going to use this wordnet dot synsets. Here I'm passing a one of the word. You can pass any word and check the synonyms for that. Active, right? So I'm saying that for every syn in this wordnet.synsets, so I'm going to apply a lemmas, right? So check this lemmas for L in syn.lemmas, and then I will use the synonyms dot append L dot name, right? L dot name is the method that I use, so that I'm going to append in the synonym, right? If L is antonyms, right? If L dot antonyms, then I'm going to append the antonyms into this antonyms, right? So L dot append, L dot antonym. So the very first one and index wise and dot name. So I'm going to create the synonyms and antonyms. Let me execute. So these are the methods that we have, all right? So that I'm going to use here. Okay, if I execute, I'm using a set here. Set will make sure that there are no duplicates, right? If I execute, you can see that active synonyms are fighting, combat ready, active agent, participating, alive, dynamic, right? Same thing for the antonyms, like active is basically stative, inactive, extinct, quiet. So here you can see the equivalent names are opposite, not opposite basically. Yeah, yeah, we know that, right? So this is basically how we can get the synonyms and antonyms. All right. Yes, that's all in this video. Thanks for watching this video. Keep learning and thank you.